Okay, welcome back. Yesterday when we left, I was having a lot of problems with this current piece of code where I would generate or try to generate some rooms, and whenever I generated, it would sometimes create a room, sometimes not create a room. I thought it was my code routine, I thought it was all kinds of other stuff, but it was a really, really basic fix, and it was in my for loop over here. Very basically, my loop for looping out and getting the values from the template, from the room template, and putting it into the level, were never actually ending in the right place. So this end value over here was incorrect. I should have been from where I start this random exposition of this room up until the length of the template, and where I start on the z-axis as well, up until the length of the template on that dimension. And if we do that, we get something that's a lot more realistic in terms of what we want. I'm still using the coroutine because that's actually quite nice, and we can turn it into a nice loading screen. But if I generate something now, you will see I'm actually getting some rooms. They're randomly placed, they overlap, because we haven't yet added the code to do that. But this is looking a lot better than the one room that we were generating yesterday. So this is really where I wanted to be at. A very basic mistake, but got a little bit caught up in trying to fix it. So at the moment, we've only got one room that we are loading. So let's have a look at adding some more rooms to our actual room collection, loading those as well, and then seeing if we can actually get different rooms to display. We're moving towards the idea of having some logic, a bit of a structure, a bit of an algorithm, which we use to actually define where our different rooms are being generated, not just this random haphazard collection we have at the moment, but we want to work towards that. So we first need to define some different kinds of rooms for that. So we should be able to open up a folder over here. See if we can just do that. Which is obviously the folder where all our room templates have been stored, and we should just be able to it's not exactly what I wanted to do. What we'll just do is we'll just open the file directly. And what I'm just going to do in that same folder, I'm just going to add another room template, which is going to call hallway. I'm going to open it up here so I can actually edit it as well. And what we want here is a long hallway. So we're literally just going to a hallway with a couple of doors at the end. So our procedural generator takes as many possible rooms as there are and randomly chooses one of those. We just need to actually load it using our load templates, which we can do in our level generator. So right here at the start, we can update this code to load another room. Now, eventually this is going to definitely need a coroutine, because loading from a file is quite expensive in terms of computational time, but at the moment this should work fine for us. We should get a random selection of hallways and rooms. Let's just make our number of rooms 10, so we've got a nice big collection over here. And now if we run this, okay, we get this error over here, which is due to our maximum template size. So because we updated our whole template, this has got a much bigger size. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15. We really should be getting this from our template, but for the moment, let's just hard code it. We can probably do this inside our actual load template. Wherever we load a template, we find the lengths. The biggest length obviously then becomes the max template size, which means we're always within our space. This means if we get very long templates, very weirdly shaped templates, we're not going to be fitting in everything properly, which is not the end of the world, because in a very real sense, we don't actually care if we are displaying an actual empty position. At the moment, I'm displaying empty prefabs with an empty tile, with this this pink empty prefab. But eventually, we'll just not display anything. We'll just need to add some logic to make sure that there's no spaces and no gaps between our rooms. Let's try that again. And there you see we get some nice long rooms, some hallways, some rooms. We're getting a structure going, but we've got two issues. The one is this empty space, which we really shouldn't be displaying. It's unnecessary to create all these empty clones. And the other is that we've got our rooms aren't connected properly. So let's fix the empty clone problem first. Now, I could just have a non-game object over there, but if I try and run it now, what it should do is it's going to give me a whole bunch of errors because I haven't assigned anything to that. So what we're going to do is we are going to update our procedural generator, our tile type. We still want empty, but empty in this case is just actual empty space. But what we also want is an error tile type. So if something goes completely wrong, we can use that to actually display it over there. So what I'm going to do is I'm going to update my number of prefabs. So we've got 6 elements. The last one becomes error. Our first one is still going to be our empty prefab because we still want a prefab there. But what I'm just going to do is in my level generator, in my display method, I'm just going to add an if statement saying that if procedural generator x comma z is not equal to tile type dot empty. Only then do we actually instantiate a new prefab. Otherwise, there's no reason for us to actually instantiate a prefab. If something does go wrong, we will still be getting the error or empty spaces so that we know something's not right over here. Okay, if I refresh it now, we get this kind of structure over here. So we're getting a much better looking, a much more interesting looking structure. And I really hope to get a decent looking structure going by the end of tonight's session, because I want to have a nice image that I actually start using for the thumbnails for these streams that actually refer to the levels that we've been creating. Okay, so just think about fitting some stuff in. Let's think about this max template size. Each template will have a different max size. If we keep the max template size and we've got some very big templates, then we won't be able to fit all our templates in properly. So what I'm going to do is, because we get the template each time we want to generate a new room, we get that randomly, I want to do that section of the code as part of my the generation over here. So every time I actually generate a new template or collect a new template from my list of templates, I also want to calculate the max template size. And that's quite easy. I don't need the max template size anymore because we are actually getting it from the length. We still do need that, sorry. First thing we do is we generate a max template size. I'm going to declare max template size over here. We can declare it as quite a big number because we are going to actually generate it over here. So the two things we're looking at are the two lengths of our two dimensions of our template. And this is the case where we could use a ternary operator, but I prefer not to. So what we're really just going to say is if template.getLength on the first axis is bigger than template.getLength on the second axis, what we're going to do is we're going to say, well, our max template size is equal to, well, our first dimension, the length of our first dimension, dimension 0. If not, because we're really just interested in X and or two-dimensional templates at the moment. If it's not that, that must mean that our second dimension is bigger, which is our Z dimension, so our max template size is equal to get length 1. That then means our max template size over here, when we're finding a starting position, will fit it in just a little bit better. We probably won't see a massive difference if we run that, except for the errors that we're getting. a mistake. Doesn't look much different, but if you imagine that we're drawing a box around if that's our 0, 0 point, we're drawing a box around it. You see it fits a little bit closer around that box. That is our 40 by 40 dimension that we've indicated. Okay, so we fixed this whole issue with our actual generating of templates. We can generate multiple templates. What we now need to do is start thinking about, well, how do we piece all of these things together? Because the levels at the moment that we're getting are random, but they're not structured. And that is one of the big things that we were interested in when it came to our actual design. We want something that's looks like an actual level. These things should be next to each other. This room should border on our actual hallway and things like that. So what we want to do is, if we go back to our procedural generation algorithm, we want to start looking at our template approach. We want to add something else over here. So we are updating our actual structure. Our Perler noise is still going to be used to create defined areas, and I'll talk a little bit more about what that means later on. And that's going to be to do with the value of an area. Certain rooms will have different values. Higher value rooms will have better loot, but better enemies. The idea being that the higher you get up this building, this skyscraper, whatever it means, you should be more likely to find more valuable and higher value rooms, but also with more dangerous enemies. But what we want to do is we want to actually add the structure part to this original structure. How are we going to do that? And there's a couple of ways in which we can do this, but basically what we want to say is that every single floor should be made out of a certain structure. It should have a certain approach to it. Basic things like you won't put two hallways next to each other, but you'll have rooms next to a hallway. Each room must have at least one entrance. Things like that. So we want to use some kind of technique that allows us to actually generate these kind of structures. I'm trying to avoid a specific word here because that's going to give away what I'm going to do with it, but we want to generate specific structures, but we don't want to have a set of 5 defined structures or 10 defined structures. We want to have as many as possible, but still all that follow a specific pattern. So there's a couple of ways we can do this, but what we're going to try and attempt to do, and like a lot of the other things that I've been doing, some of these things are things that I know work, or techniques that are used for this kind of thing, but I might not have implemented in specifically this way. But we are going to be using context-free grammars, or actually just technically we're going to be using grammars for this. So this is a whole different kind of approach, but we're going to talk a little about that. So what I want to do is I want to add a new card. We'll add it to the busy pile because that's what we're going to be doing. It's going to be our level grammar. And I'll explain what I mean by grammar right now, after we just add a label to it. This is just a game design level actually. We're game design code actually. So the idea behind a grammar is, and you will see if you search for formal grammars, it's a set of rules for producing strings. So this is very much used for in language, natural language processing, and in programming and programming as well, where you define specific rules, and these rules then allow you to actually define any kind of new strings or sentences based on that. So we are technically going to be using context-free grammars because we want this kind of structure, and I'll talk a little bit about what this means later on. But basically, we are going to say that we've got a entity or a value. The technical term is a terminal, I think. No, terminal is well, a string, and each one of these strings can then possibly be converted into other strings, and then these strings can then further be converted into other strings. Okay, so this is not the best explanation of this, but let's look at an example from something that's a little bit more closer to home in the programming space, and that is a grammar for a binary operation. Now, a binary operation is where we've got something like 5 plus 5, or 7 times 4, or 3 minus 2, or whatever. So there's essentially an infinite amount of possible binary operations that we can define. We're taking two values and we are performing some kind of operation on them. So if we are writing a calculator or a little parser, you still need to know if this is a valid binary operator. Are we performing an operation on two different numbers that we can actually work for? So obviously we can't define and list every single possibility, so we need to kind of convert this into this formal grammar that we can work with. So I just want to go back so we can get the notation a little bit better, but we want to use this basic idea. The idea is that we have our small letters being terminal strings, so A and B can't be converted into anything else, and our big string S can be converted into other smaller strings. And then this means we can build up and build up and build up until we eventually can't make any more different strings. So if we go back to our example over here, we want to be able to define a binary operator we're going to call B, and B consists of any number then either the symbols, and there's different notations for it. I'm just doing a bit of a haphazard notation, but plus, multiply, divide, and minus, and any other number. So from this grammar we can create any valid binary operator, and we can also see that, well, we can actually look at an existing binary operator, and see if it fits this pattern. Where binary or where our give me a second, sorry, where our grammars get really interesting is when we start combining them. So we say that if we've got a calculation, which we're going to call C, we're going to say C is any number of binary operations that we can add together. And that'll actually allow us to chain all of these binary operations together. As you'll see, this doesn't work out exactly right, and that's why very often this will be written in some other kind of notation. If we look at another example, we might say that in English we've got a sentence, and a sentence must consist of a noun, a verb, and an adjective. And then a verb and adjective. A noun can be one of these three things: cat, mat, hat. Verb can be sat, ate. Now adjective, so we add verb actually. Hastily, hungrily. These are not the greatest examples, but hopefully they give you the idea what we're talking about. And then from this, I can basically randomly pick any noun, any verb, any adverb, and I should be able to get technically a functional sentence. So I could say cat sat hungrily. So you say, okay, this doesn't really make sense. So we can say, well, we start with the word the and any noun, any verb, and any adverb. So then our sentence become: the cat sat hungrily, the cat sat hastily, the mat sat hastily. The important thing here is to keep in mind that we are creating sentences that are correct according to our grammar, not necessarily according to an actual grammar. By actual grammar, I mean normal English grammar. Or, in a more precise sense, the mat sat hastily is a grammatically correct sentence, doesn't mean it makes sense. Okay, so what does this mean for our procedural generation? Because I've spent quite a bit of time talking about this now. But the fact is, we can use the same structure to generate valid levels. And by valid, we mean whatever rules we define. This doesn't mean that the rule is going to be fun to play, but it should be a rule that a level that makes sense for us. So what I'm going to do is I am going to start defining a grammar for us over here. We say we're going to have a level. Level always consists of an entrance, and any amount of connections, that's a little clear about. A level always has an entrance plus any amount of areas. Okay, entrance, and then here's capital letters are symbols that we can change, and small letters will be actually referred to room templates. So we haven't defined all these room templates, but an entrance would be staircase or elevator. elevator, using the pipe symbol there for our to denote the OR symbol over there. I'm going to use I just want to play around with my syntax for myself here. If we add a star in front of it, that means there can be any amount of that actual symbol. So an entrance and any amount of areas. What is an area? An area is a connector and any amount of areas, because we can chain them together, and then area becomes recursive. So what this means is that our levels will always have an entrance and 0 or more areas. We would ideally like at least one. An entrance is either the staircase or an elevator. Our area is a connector, and then any other areas as well. So that means we can then chain them together. So this area could become another area and another connector. But we always want to make sure that we've got some kind of connector connected to our area. Now, what is okay, sorry, just my brain catching up to my mouth over here. Our area can either be a connector plus an area. It could be a connector on its own. We could have a hallway leading off into nothing that never got finished. Or it could be one of our existing rooms, which would be room 1, room 2, maybe room 3, etc. So this is a very basic grammar, but hopefully this gives you an idea of the kind of thing that we can do. If we start thinking about what kinds of things should be within our game, within our building, we can add things like foyers, meeting spaces, open areas, labs, prison rooms, whatever it might be. There might be a whole bunch of different kinds of things that we might want to be able to add to create more logical sounding, more logical levels. So what this means for us is, if we use this structure, we should be able to create levels that are sensible. We still need to make sure that they align, so that's something that we need to keep track of, and we still need to make sure that they end at some point. So our recursion through this grammar can't just carry on forever. We need to stop at some point. But very importantly, this does give us something to work with. So I'm going to save this, and I'm going to move it to our done column, because we are done with it for now. For the purposes of our first prototype, this is more than sufficient. So what I need to do, I just need to define a couple more rooms. One thing I did miss, of course, is what the heck is a connector? We don't have that defined yet. A connector can either be the hallway that we've defined, or let's just say a junction. A junction really will probably just be a small open space with doors all around it. So it's a connection between all of our rooms and all of our areas. Okay. So we need to define staircase, elevator, room 1, room 2, room 3, hallway, and junction. So let's go into Visual Studio and let's start defining all this room. We've got hallway, which is a room that is 4 high and quite a lot long. We want to define junction. Look at our hallway. Our hallway is 4 high and 4 wide. So if we just write that, we should get a nice hallway. We've got a room. Let's put our crates back in our room. Let's create room 2 and room 3 as well. Okay, so room 1 is a room with some crates in it. Room 2 has got no crates in it. But it's got doors on either side. In room 3, I'm going to make into a slightly larger room, which actually doesn't have doors, but open spaces all around. And a wall right in the middle. Okay, so let's just test if all of these work. Let's go back to Unity, increase our level size a little bit. I don't want to make my number of rooms a value that we pass through to level generator right yet, because the idea behind it is that this number of rooms will be based on our actual grammar that we're going to use. But let's add these different rooms. Oh, there we've got hallways, we've got our new room 2, we've got our room 1, we've got our room 3, we've got our junction. Junction is not overlapping, not showing it properly. As you can see, we are getting some interesting options over here. Just want to check something. junction didn't have rooms on the other side. So we're creating a whole bunch of rooms. What I want to create is just use the junction for this. So and I'm going to call that a staircase. So we're adding a new item there called a new tile type, which will be tile type 6 in our tile type, which is going to be staircase. Okay, we should probably create a prefab to actually showcase that. Now I don't actually want to be doing any 3D modeling because that is this is obviously not what we're going to be doing within Unity. So let's just make it our metal color. So anything with a metal color will be our staircase. We just need to go back to our level, prefabs. Our 6th element is staircase. Our final element, our 7th element, is still empty. Okay, that should still get us with some staircases as well. Okay, I say staircase, but really it's a tile that allows you to move a starting tile in this level. So every level you start from this staircase. The idea is you can only move up, and this is where you end up into the new staircase. So I'm going to take the staircase, copy it, add elevator. I'm going to be a little bit lazy. All that our elevator is an option where all 5 of our middle tiles are stairs. Okay. And close all these additional templates we've created. Let's just load our staircase and our elevator. And now if we go back to Unity, if we run it, we get 2 elevators. That's a staircase, that's a junction, that's a hallway, it's another staircase. There's a bunch of rooms inside each other. All very exciting. Something I like to do is, after saving, is to pump up the size of what my level is, just so that we can see what's going on. And we've got a whole bunch of stuff all over the place. Quite far apart because our level is quite big. Let's increase the number of structures. We're getting something that's looking interesting. We want these things to be next to each other, and we want them to be placed in such a way that it makes sense. But at the moment, we've got something that's starting to look a little bit like an interesting level. So, how do we get this into something that's a little bit more structured and a little bit better without having to manually create a whole bunch of levels? And that's where our grammar, our context-free grammar, actually comes into play. Now, we're not going to be implementing a full parser. The context-free grammar is really just an idea for us to create the logic behind what we need. So we're going to need to start looking at our code and start thinking, how can we abstract some of the stuff out of it? Because it's getting a little bit difficult to work with. So the first thing we need to worry about is the fact that in my level generator, sorry, my procedural generator, I'm just randomly picking a new template. I don't care what it is. I don't know what it is. So I would like to be able to actually, when I pick a template, I want to be able to pick a template that I should be picking. I probably want to have one template for my entrance, or an array of templates for my entrance, sorry, that's either staircase or an elevator, an array of areas, which are my rooms, and an array for my connectors, so I can randomly pick one of those each time. Also, I can keep track of how many I've picked so that I know at which point I probably need to stop picking more of them. So I need to have some way of actually defining what kind of room this actually is as well. And there's a couple of other things that have been getting quite frustrating. Template.getLength.0 for the width, and template.getLength.getLength1 for the height is not a very user-friendly way of actually defining our template. Also, max template size is not something we should be calculating each time we pick a template. We should be doing this once. So all of this really tells us that what we need is another class. We need a class for rooms. Okay, what is a room class? Well, this is actually quite easy to define. A room class has got a room type. Once again, we're going to be quite structured. We're going to use an enum for this. Our room types are based on our grammar. So entrance, connector, and area are our room types that we can possibly have. Okay, our room then obviously has a room type. It has a template. And it has a width. And obviously it has a height as well. So what this means is in our procedural generator, we can start making our lives a little bit easier. First of all, our room templates is not a list of tile type arrays, but rooms. Make sure they're in the same namespace. When we load our templates, we are actually declaring a new room. And we can then get the values that we want for our room height and room width. And we can neaten up this whole process a little bit. So instead of doing all the stuff with, I just need to neaten up my indenting, temp.length and lines.length, we could do that once. We load that into a room. Our room has got height and width. So if we want to get the max template size, we can add that as a method to room. And basically we use exactly the same logic we have over here. Except in this case, it's obviously width and height. And instead of setting max template, we just return width, or we return height as our max size. In fact, we don't even need to do that. We can just replace max template size with r dot max size. And r dot width and r dot height make a lot more sense than template.get length 0 and template.get length 1. So r dot template is the value that we want over here. Okay, so we've got our room, procedural generator. Last thing we want to do is to add a constructor. In our load templates, either one of these works, but eventually what we'll need to do is we'll need to store the type of room that it is inside the file itself. I don't want to do that right now, so I'm just going to hard code that for now, where I'm going to say, well, we load a template, and one of the things we want to pass through is room type, and then after we've created our file, our room, we can say r dot type is equal to room type, and in our level generator, whenever we load a room, we just say what kind of room type it is. Dot area. And as you will hopefully start seeing, this is how we can actually start building up, or knowing when we need to make decisions about our actual grammar, if it works. So before we get into the grammar itself and trying to implement it, let's just make sure that all these changes of creating a new room, adding it to our procedural generator, assigning different room types, if that all works. No errors as far as I can see. Little spinny wheel of death. Always one, always one. So this little helper function that we've created over here to display a specific template, it's actually displaying rooms. So we just need to say that the template it needs to display, it needs to get from the template inside the room class. Let's clear it. No more errors. No errors when we run it. And it's still generating. Okay, so now we're actually generating rooms instead of these 2D arrays of tile types. Internally, it's still 2D arrays of tile types, but we've nicely encapsulated all that logic inside a room class, which is always very nice to do. So we've got all these rooms and things being generated all over the place. Let's start thinking about how we can actually add some logic to what we want to do. So we're going to be building this from our grammar. We've defined that our entrance area, our level starts with an entrance area. So entrance area can either be a staircase or an elevator. So we need our procedural generator to randomly choose a staircase or an elevator. So either we can loop through all of our rooms, and only if one of them is a staircase or elevator we pick it. Otherwise, what we can do is we can just create arrays for entrances, areas, and connectors, and add the rooms as appropriate. And that's going to be the easiest to do because we've already defining what their types are when we actually create them, when we load them. So in my procedural generator, I am going to change this to area templates, entrance templates, and connector templates. And what we need to do is we need to figure out what kind of room this is before we add it to the appropriate list. That's just a basic if statement. I'm just going to take a quick break. I just want to sort some other stuff out, but should be back in a bit. Let's carry on. Sometimes real life gets in the way, but what we just want to do is we just want to actually do some testing with our types. And this is the basic structure that we want to follow. Let's just add some spacing. And we call it area templates, yeah. So it's area templates. Or connector templates. Or of course entrance templates. Okay. What I'm just going to do is in my constructor, I'm just going to initialize these three array lists that I have. In trans. Okay. happens now over here is, for every room, before we create it, we need to decide what kind of room are we creating. So what I'm going to do is, I'm going to try something over here. Our grammar, and this might not be the best way to do it, but we are still just working around. Our grammar basically is always recursive. So it's always, what was the previous thing that you made? So if you made an entrance, then you get to make an area. That's the next thing you can make. If you make an area, well, then you can make either a connector or an area. So we're always going to keep track of the last room that we've made, and then try and make another room based on that. So what I'm going to do is, I am going to take out our starting X and Y, because we only want to define that originally. Our initial start X and Y will be random. After that, everything needs to link to that. And for our first try, we're just going to link in the line to see if we get our actual room template working properly. R.max size doesn't really matter in this context. Sometimes you think you're going to need something, but you don't really need it. If we're not randomly placing rooms, so long they are we still need a max size though. I don't really want, there's a question of, do we want, I'm going to create another list over here, which I'm going to call all templates. Sometimes we might just want to get something from all of our templates. Our rooms are going to be added to a specific template so that we can randomly choose one from that, but we're also going to add it to all templates so that we can do things like the following. We're going to go through all our rooms. We are going to check each size each time if the max size of that room is bigger than the previous max template size we had. If it is, we will then make our max template size equal to this new max size. So this will mean we'll run through all our rooms and find our absolute biggest size. And this gives us the knowledge that we can actually create new rooms within our 40 by 40, our 50 by 50 grid, whatever it might be. Okay, what we then need to do is we need to have a actual room type, which is going to be the last room that we've created. What is the last room that we have created? Well, for completeness sake, I'm going to add a none value over here so that we can set it up initially that the last room we've created is room type dot none. We haven't created any rooms. Then, for all the rooms that we want to create, we're going to say if room type, if last room equals room type dot none. Well, what do we do then? Else if last room equal room type dot entrance. Oh, I think I created one too many. But hopefully you can see the logic of what I'm getting at here. This is not perfect, but it should at least help us generate the kinds of rooms that we want. So if our last room is equal to entrance, what do we do? If our last room is equal to connector, what do we do? And if our last room is equal to what's the last one? Area. What do we do? And this is where our little grammar comes in. If our last room is a none, in other words, the first thing we need to create an entrance. So in that case, it's going to yank this line over here. We're still going to be using we want to randomly pick an entrance template. If our last room was an entrance, and then we need to set, obviously, well, our last room is equal to room type dot entrance. This way, hopefully, we'll also only ever create one entrance. If our last room type was an entrance, well, what do we say are our rules? It's either we need to choose one of those, and then we need to choose an area. An area is either a connector or an area. So we need to have a random over here. Well, it's either going to be a connector or area. 50-50 chance. And we can always play around with that. So it's either going to be something from the area template, or something from the connector template. Obviously, depending on which one we choose, we change last room again. Area. Both connector and area can be more connectors or more areas. We don't have the most complicated system over here. So we can say, well, depending on what your last one was, we don't really care. We're going to give you a 50-50 chance of generating one of those. Okay, let's do this with typing. We're still going to be randomly generating them, but we should be generating them in a little bit of a better order. So just so that we can see what's happening. Because once we generate them, we don't know in what order they were generated. So the order is quite important for us. At this point, my display template is becoming more trouble than it's worth, so I'm going to comment it out. We don't need it anymore. We're displaying entire levels now. Ooh. Of course. We just need to define our old templates. One of the only, not really an issue, but if you're working with lists, always remember you need to initialize them at some point before you can start adding things to them. Oh, it's getting stuck in a loop where it's generating. Let's just place that in a better spot. We don't need to say for every single tile what we're displaying, just for each one of our entrance, and then a whole bunch of connectors, which would explain why. Well, we're getting these things on top of each other. Remember, we're not changing the random position of where they start anymore. I would just like to get a couple more areas. I think it's because it's returning an integer. Oh, look at that. We've got an entrance and then 2 areas and a connector, 3 areas, 2 connectors, areas, a connector. And what you should get is, well, all of these things, they are all there. They're just not being positioned correctly. So what we're going to do is we're going to cheat. And after each time we do this, we're going to say start x plus equals still not going to get us exactly what we want, but you guys should see something interesting if this works. Hopefully you can hear the excitement in my voice. Yeah, knew that was going to happen. Ooh, I told you we need to basically what we're doing over here is so long or the moment we get outside of, or we see that we're going to get outside of the maximum width, we choose a new starting point. Otherwise, we just keep adding onto our rooms. And we slap them all together in a long line. And as you can see there, we had a nice long room, connectors, areas, I don't know where the areas went to. And then we still hit the edge. We've got some clipping because we've got stuff on top of each other, but that's not the end of the world. X is width, right? Try that again. Come on, no. We keep getting to the edge of the map and then running out of space. Why is that? Might be the height that's also causing some problems. One more option if this doesn't work. We are generating the max template size for a reason, after all. That error message is just Unity not playing well with my our junction cutoff. Doesn't want to create obviously connector. We decided on the type of room we generated because we know our first X and Y positions are within the arrays that they should be. We generated. After that we check, well, if the next room that we want to rate, we want to generate, if that is going to be outside of our size, our maximum sizes, which we check every year, then we choose a new position. might still be the height. It's just my cloud syncing service that's giving me problems. Okay, it's got my X and Y's confused. Oh, we're getting 2 rooms. Let's have a look. This is something that's playable. Junction, junction. This room is a stupid room because it doesn't have any doors. Over here, a bunch of stuff has been created on top of each other, which is a bit weird. Oh, we've got a junction with an empty space that the player can lose their lives into. Our flow is not as high as low as what it should be. Should probably fix that. We've got some stuff overlapping, but we have a whole bunch of stuff that gets generated until we get to the edge of the map, and then a whole more stuff that gets generated until we get to the edge of the map. We probably need to fix this properly. This was a good idea in sounded like a good idea, but actually we want different responses. If the previous room was a connector or an area. If it is a connector, well, please create an area for us. If it was an area, please create a connector for us. This way we always know everything is connected properly. We can play around a little bit with this logic to get something that's not as strict. Connect area, connect area, connect area, but this should at least not have any of the weird situations that we've been having. The previous time it ran without errors, I had a feeling it was too good to be true. We're getting the area connector thing, but we're still reaching the edge of the map and then running out of space. So let's play around a bit. This is something we need to do anyway, because at the moment we're just creating these long streaks. Let's randomly choose whether we're going to continue on from left in horizontal or vertical fashion. So either we just create rooms that are next to each other in terms of the width, or we create, which we don't want to do. So we're now going to create have a random function which is going to randomly decide whether we go up or down, essentially. I had a lovely random function which I just deleted, but that's fine. We can steal some of that code. So if the random value between 0 and 1 is greater than 0.5, 50% chance, we add the start x, we add to the width of the start x, otherwise we add to the height of the start x. This might ironically fix our won't necessarily fix our random generator function, but hey, look at that. That's looking a little bit more like an interesting level. Some of the areas you still can't actually reach them because they're not designed that way, but we are getting into some interesting level design over here. This is really looking good. Just need to sort this issue out. This issue is, and it can only be due to the sizes over here. So I am just going to add a debug.log start x start z. That was 100 by 196 and 40. That's only 4 blocks, so an area, all our areas are bigger than 4 blocks, so that's why it's going over that. But that should be within the start x plus max template size should be bigger than equal to width. So is my max template size being generated correctly? Fifteen should be fine. And this time we get higgledy-piggledy of junctions next to each other. We get something that is an almost actually playable level. Let's see if we can find our entrance. There's our entrance. Our player can go through that door. They will need to not die if they go through there. I mean, through that door over there. We actually have an interesting option over here as well. Okay, we still have a possible issue with the random generating it in really weird places, but this is feeling good and feeling a lot better. Let's think about the fact that we still want to try and figure out why we are sometimes running into this null point exception. We have the -1 over here because we want the templates to actually overlap, so we don't have two walls next to each other. This -1 over here might just save our bacon because '96, 86 plus 15 is not going to be enough. So obviously it's trying to generate a hallway over there. Now, problem is whether we're getting into our random generation at the right point or not. See, that 84 was getting too big, and then it reset to 60. But it doesn't always want to do that. '94, it's not getting into this. It's doing a before and after check. Seven 43, then it goes 46. '80 and 65. '80 and 65. That's what we have over here. That still doesn't fit. Comes in again. That's because that's the start position. So we're moving right up to the edge of the map and saying, okay, That's where you ended, right at the edge. So let's start right from the edge. That seems a bit better. Interesting structures that we're getting. Yes, we are wasting a lot of polygons because a lot of them are hidden and we don't need them. We can think about the culling that we need to do, all those great kind of things, but we have got something that looks almost like a workable level over here. Let's just do a maximize on play, run it again. That doesn't help us because we don't have our camera system properly installed. Let's move the camera around. 50, 50, 20. Just playing around with the camera a little bit. There we go. We'll make the camera movable later on, but what I really wanted to do is just end of the session because we've almost been spending 2 hours. So I can run it in maximize and play mode. Get a nice big view and then snip it. So that we've got something cool that I can eventually use for my uploads, things like that. the current view is almost good enough. Cool, and we've captured the entire window that I'm actually looking for, which will make a nice, better looking screenshots than the ones that I've actually been using. I'm going to call it a day, an evening over there. We've managed to fix our problem that we previously had, which is really nice. We've managed to add a whole bunch of new templates. We've managed to add a very basic grammar, but it is working. And we managed to stick everything together, not randomly place everything all over the show. What we now need to do is to do rotation of our actual templates. We've got all these long hallways which are all horizontal. Sometimes the hallways will need to be vertical. And very importantly, what we also need to do is to make sure that wherever we've got doors, things actually link up and connect. We could either just add doors to all the walls of our levels, or we're going to have to think a little bit carefully about how we can actually do that. But we've got a structure here that allows us to do that, and we can play around a little bit with having there being a higher chance of being another area instead of just one connector. We can have a little loop here which gives us 2 areas for every connector or something like that. Lots of options that we can do, which makes our lives quite nice and allows us to do quite a couple of cool things. I hope you guys watch this, because I don't think anybody actually watched it while it was being live streamed, but that's fine. We'll enjoy this, and we'll see that sometimes you get stuck on an issue like I did at the beginning or from last time, and all that you need to do is just take a break, because the fix is actually something really, really basic. Honestly can't remember what the fix was now, but it was something really basic, and I was doing all kinds of complicated things with coroutines, and none of that was really needed. Hope you guys enjoy that, and join me soon when we will see if we can get another 1 or 2 steps further in the procedural generator going. Hopefully in the next session we'll be able to finish off this section of the procedural generator, that we can start looking at some of the other concepts that we need to consider in terms of actually playing the game, movement, enemies, all those great things. That's it for tonight, but hopefully enjoyed it, and see you again next time.